Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the WaterJet tutorials series here. So probably tomorrow I'm going to be ordering this hosing and see what I can do about the whole 6-month lead time and see if I could tighten that up and see what we can do from there. But I think this might be the last video for a while until I get some of these parts in, and I could modify these drawings so that we could fix that up. So, and then maybe we'll actually do some videos showing how to program this guy at some point, so you can get some idea on kind of some of these more elaborate projects. Okay, so we did the 4-way cross, we did the M14 fitting, we did the 9/16 fitting. Now we need to do the 7/8 fitting, and in order to do that we need to do the 90. It's very similar to the output 4-way cross. So this one's going to be 90 degree 9/16 to 7/8. So now pretty much what we're going to do, and of course all this stuff is stainless. Well, I guess one thing that we could do is we could do an actual model of all these things that are in actuality, and then kind of model the hosing that goes from one area to another. That's something that we could do. See, it's 1 inch by 1 inch square block. I mean, square is the easiest to drill on the side. I was thinking to do a circle because the bottom is going to be a circle, but I don't think that's necessary. So we don't want to make this that tall because, again, we want basically the clearance. Right? We basically want the clearance, so if it sits underneath the mill, it could do so. So let's go here. Let's draw. Let's project. Oops. Now, actually, this is going to be too deep. Section analysis. And then this, of course, basically needs to be the middle of the part, because then the beam has to go straight down. So let's say that I think the other one I had was a 0.2 hole. But obviously not all the way through the back. I think that's okay. Alright, so basically what is this distance from here. .937. And also another thing that these guys are going to have to do on this particular one, actually, yeah, they're going to have to go in there and basically do end mill, because they need this basically to be square. Actually, go in there with a ball. A ball would be preferable. So have an edge radius here. So basically push in there with a ball. But this is 1 inch. So let's say that this is 2 inch. Well, I mean, it doesn't have to be equal. But I'm going to say this one at least go 1.5. Actually, we do want to equal, because then they can't lathe it. And then it becomes difficult. Maybe I could ask them what they would prefer, because if that was the case, then this would have to be 2 inches. It'd probably mill both sides. I mean, the other side, the location is not that important. So this could probably be okay at 1.5. Then basically down here, we have to go here, project, include. Oops. Right there. And then this is going to be 7 divided by 8. Wait a second. No, this is going to be the 1/4 inch hosing. Right. So this is going to be a 1/4 inch hosing. And then we need room for the flare fitting. So let's say it's about 1 inch tall. And then we're going to go up here. Let's do a center line. .125 and 60. Okay. Yep, cool. So Now here's where it gets tricky. I do like this. This looks good. I just need to drill this one a little further. That one, this one. Yeah, that was weird. And this did, what the hell? What? Oh. And also this does not look like it's 60. So let's just go in here, delete everything, start over. Okay. I hate it when this happens. Are you okay? Okay, now you like it, okay. Profile missing axis cut. Okay. Offset. What the heck? Oh, technically it should have been. bit or whatever. Let me see, I'm making a lot of mistakes here. So yeah, basically just go down there with a ball nose end mill. Why is it all so big? Now I need to align this. It's out of alignment now. There we go. Okay, that's good for now. And let's add a little fillet here to increase strength. At least 1/4 inch radius and 1/4 inch end mill. Wait a second. And there you go. And then this just uses the same 9/16 fitting as all the other ones use. Oh, and then here, oops. Oh, sorry, that's going to use a 7/8. We're going to 7/8, I forgot. It says 9/16. I can't remember, it's in this one. I mean, in actuality, I could pretty much use whatever the hell I want. 9/16, 18. So I'm making the collar and doing all of this stuff. There you go. See, I don't even know, how would you even do that on the inside? Is there even an option in the hole? No, it's not even an option in the hole. I'm gonna have to think a little bit more about this one. If we have a chance, I will look back at this one, but let's do the last fitting. What the heck? Okay. Ooh, but this needs a custom, not a tube. Right, because basically, if you guys remember, this is basically what it looks like here. We have to adapt this cutting the orifice, which is here, which I determined the angle to be 30 degrees. So instead of what I did here, it's actually going to have a negative kind of camber look into it. So basically, instead of like this, and also we want it to be strong, so because it's big in diameter, so if we did I mean, we could do 1/4 inch, but I don't know if even the hole is that big. So it looks like we are going to have to do a different, what's it called, a different hose here. But basically what I was thinking is you just, instead of that, you do down this way. So let's see, what do we need to do here? Maybe 0.325. Because again, we can't just make that however we want. It's got to have a certain tap on it. We can do 3/8. Oops, not that one. Or we could even do 1/2 inch. Half-inch threaded. And then that means that, so we have about 0.3 meat left over. Let's take a look. Not metric. Okay. So here's some standards. So like 7/16. Which is like 42 something. Is that 43? Okay. Okay, that's a big boy. All right, now basically what we're gonna do is let's go to this. Okay. Okay. Oh, and then go straight up. Droop. And actually, we don't want. We don't need this to go perfectly over to the edge. So something like that. Uh-oh. Okay. No, this. this one, axis this one. Okay. And obviously what it's doing is it's beating the crap out of it because it's really small. So here we're going to go 7/16, which is this one. Left hand model full. So there you kind of have an idea, and it's okay if this part here gets blown out. But you can see how deep it is. So maybe even drop this down a little bit. Which one was it? That wasn't this one. So let's say it's 0.3. Ooh. 0.30. There we go. Ooh, but now it has to fit in there. Okay, so pretty much what I'm thinking right now is this. Not that one, this one. That's cool. There we go. Who cares if the surface gets jacked up? Who cares if that surface is thin? Most of it's going to hit here. Some of it's going to hit outside. Most of it's going to be contacting here where it's strong, and then it's going to have some area where it's weak. But as long as it's contacting where it's strong, it should be okay. Okay, it looks like, so that's basically what we're looking at there. Oh, that'll break off. That's okay. So that's kind of what I'm thinking, and then we'll have to do a setup for that stuff in the next video. Alright, so I guess we do have a little bit more content with the water jet. We'll do one more tomorrow, and then it'll be weekend and do programming stuff. Alright, thank you guys for watching, and I'll see you guys next one. Take it easy. Peace.